5 steps of collagen synthesis, 5 answer choices, and they all look correct.
They do. But the stem hands you one word that quietly kills 4 of them. Miss that word, and you're guessing between 5 diseases.
One word?
One word, let's go find it.
Quick, hello. I'm Yue. And this is the USMLE Reasoning Lab, where we don't memorize answers. We build the logic so the answer falls out.
If that's how you like to study, subscribe and follow along. Okay, the case. A 3-year-old girl. Her skin bruises and splits with everyday handling. A light bump leaves a wide purple patch.
That's more than a clumsy toddler.
Right. And last month, a scraped knee opened into a wound the clinic could barely close. The skin pulled apart around every stitch.
Huh. So the skin won't even hold a suture.
It won't. Hold on to that. Fragile skin that tears around stitches. That's a real clue, not just a color. On exam, her skin is soft, hangs in loose folds, and stretches much farther than normal before springing back.
Stretchy and saggy.
Stretchy and saggy, plus bruises over both shins and a small bulge at the belly button.
A hernia.
A little umbilical one. Keep a running list: fragile skin, stretchy skin, easy bruising, a hernia. What do those 4 share?
They're all connective tissue that's too weak.
Exactly. Whatever this is, it's a collagen problem. The only question is which step. Then the biopsy. The staining shows collagen that never matures into normal fibrils. And here's the line that matters. The defect is in the processing of collagen after it's secreted from the cell.
Oh, after it leaves the cell.
After it leaves the cell. That's the word, extracellular. Underline it. That one word is about to eliminate 4 of the 5 options.
Let's see the whole thing.
Here's the question. Which step of collagen synthesis is most likely impaired? Your choices. A. Glycosylation of hydroxylysine residues. B. Interchain C-terminal disulfide bond formation. C. N-terminal propeptide removal. D. Proline residue hydroxylation. E. Triple helix formation.
Lock in your answer. 5 seconds.
The answer is C. N-terminal propeptide removal.
And you said that word extracellular gives it away. Why?
Because of the 5 steps listed, only one happens outside the cell. So before we touch a single disease name, let me show you the assembly line. Once you see where the wall is, this stops being memorization. Think of collagen like cable made in a factory. The finished strands roll off the line, but each one still has a big chunk of foam packaging stuck on both ends.
Packaging on the ends.
That packaging is called the propeptide. It's bulky and it's charged, so it holds the strands apart. As long as it's on, the strands can't pack together.
So somebody has to strip it off.
A worker at the loading dock outside the factory snips the packaging off. Now the bare strands stack tightly, staggered, into a strong cable. That's a real collagen fibril.
And in this girl,
the worker is missing. The cable still gets made. Every earlier step works, but the packaging never comes off. So the strands stay loose, and the cable is weak. And weak collagen is exactly what you're seeing. Skin that tears, vessels that bruise, tissue that can't hold a stitch.
Wait, so the collagen is actually made, it's just never trimmed.
That's the whole disease in one sentence. Made, secreted, but never trimmed, so it never packs. Now let's walk the real line and watch for one thing only. The moment we step outside the cell. Inside the cell, 4 things happen. 1. The chain is built with glycine every 3rd spot, because glycine is the only residue small enough to sit in the center of the coming triple helix. 2. Proline and lysine get hydroxyl groups added. Little hooks. 3. Sugars get added onto those hydroxylysanes. 4. 3 chains line up and zip into a triple helix.
So by the end, inside the cell, we've got a finished triple helix.
Finished, but still wearing its end packaging. Then the cell secretes it. That's the wall. Everything after this is extracellular.
And outside?
Outside, only two things happen. 1, the packaging gets cut off. 2, the strands get welded to each other, cross-linked into the final strong network. Cut, then weld, that's the entire outside. Now go back to the options with that wall in mind. Extracellular means only the cut or the weld.
And the weld isn't even an option.
It isn't. So the only extracellular step on the list is C, removing the N-terminal propeptide, the cut. You didn't need a disease, you needed a compartment.
So the trick is read extracellular first, then just ask which option lives outside.
That's the move. Compartment first. The disease name is the reward, not the road.
Then walk me through the 4 we threw out.
Happily, because each one is its own exam question hiding in here. D, proline hydroxylation, inside the cell, and it needs vitamin C. Take away vitamin C and you get scurvy. Bleeding gums, wounds that won't heal. It's tempting because scurvy bruises too, but it's intracellular. Wrong compartment.
So scurvy is the vitamin C version.
Right. E, triple helix formation. Also inside, swap a single glycine and the helix can't zip. That's osteogenesis imperfecta. Blue sclerae, bones that fracture. Different child, different story, and still inside.
What about B? That one looked sneaky.
Oh, B is the trap. Interchain C-terminal disulfide bond formation. Those disulfide bonds line the 3 chains up inside the cell before the helix zips, so it's intracellular. And look at the verb. Formation, not removal. Forming the bonds is inside. Cutting the packaging is outside. One word, opposite compartment.
And A?
A, glycosylation of hydroxylysine. Inside in the endoplasmic reticulum. No trip outside at all. Gone.
So all 4 losers are stuck inside the cell.
Everyone, C is the only ticket out.
Okay, here's my real worry. This question was kind. It said removal. What if the next one just names an enzyme and asks which one is broken?
Then you use the suffix. The letters right before ASE tell you the reaction, and the reaction tells you the compartment, the cofactor, and the disease. 3 enzymes, 3 suffixes. Hydroxylase adds a hydroxyl hook. That's inside, it needs vitamin C, and losing it is scurvy. Proteinase cuts protein. That's our packaging cutter, called ADAMTS-2, working outside. Lose it, and you get this girl. Ehlers-Danlos, the fragile skin type. Oxidase, that's lysyl oxidase. It oxidizes lysines to weld the strands together. Outside, and it needs copper. Lose the copper and you get Menkes disease.
Hang on. There's a lysyl hydroxylase and a lysyl oxidase. That's cruel.
Huh. It is. So here's the tiebreaker. Lysyl hydroxylase adds an OH group and it works inside. Lysyl oxidase works outside and it needs copper. 3 O's. Oxidase. Outside. Copper. Say it once and you'll never mix them up again.
One thing still nags me. Why so much bruising? Collagen is a structural protein, not a clotting factor.
Good instinct. 2 reasons. First, collagen is the rebar inside small vessel walls. Weak rebar, and the vessel tears with a light bump. Second, collagen is the packing around the vessel. Normally, that tissue squeezes a small bleed shut. Weak packing, and the blood just spreads into a big purple patch.
So it's not that clotting is broken.
Clotting is fine, the scaffolding is soft. So vessels tear easily, and nothing pinches them shut. Now change one thing, same extracellular biopsy. But now the defect is the weld, not the cut. Cross-linking fails. Which enzyme?
lysyl oxidase, and that needs copper, so I'd be thinking Menkes.
There it is. One variable moves, cut to weld, and you slide from Ehlers-Danlos to a copper problem, without ever leaving the outside of the cell. That's how you know you understand the line, instead of just matching a face. So the rule, on screen word for word, read the compartment first. Extracellular collagen means only 2 steps. Cut by a proteinase, that's Ehlers-Danlos, and weld by lysyl oxidase with copper, that's Menkes. Everything else is intracellular, and given only an enzyme, its suffix hands you the reaction, the compartment, the cofactor, and the disease.
Compartment first, then the suffix does the rest.
That's the whole episode.
If that made the collagen steps finally click, subscribe. We do one of these a day, and they build on each other.
See you in the next one.